first, a story. So I'm at a block party a couple weeks ago, and I'm talking to one of my neighbors, and I'm trying to explain CoLab. And I say, yeah, we're building all sorts of prototypes with blockchain, artificial intelligence, distributed web. And he says, oh, I went to an AI conference about 30 years ago at the Heinz Convention Center in Boston, and it was all the geeky people you'd expect making promises about what AI was going to do and how it was going to transform our future. I couldn't actually get an image from it, so I took the image from 1983 War Games. That'll come up again soon. And then, he said, I went back to the same conference this year at the exact same auditorium, the exact same convention center in Boston. And it was the exact same geeky people making the same claims about what AI and machine learning were going to do for us in the future. It's just that this time everybody was 30 years younger than me. So the question is, what's changed? Right now we're talking about a lot of the same AI conferences, AI concepts that we were in the 1980s. And there's a few things that have happened recently that make this different. But when we talk about AI, we're kind of stuck on this idea of creating an intelligence that is bigger than we can imagine a computer would be capable of taking on. Years ago, that was, I can't imagine that a computer could route me from San Francisco to New York by car. Or I can't imagine, in 1983, that a computer could calculate all the trajectories of intercontinental missiles and play out the scenario of what thermonuclear war would turn out to be. But what's different now? What's different now is we're seeing advances, but it's coming from a field, maybe a subfield of AI called machine learning. And here we're talking about an algorithm that I'm training on a data set, and then I'm feeding more and more data back into it so it gets better over time. And the reason that's getting better, two reasons. One, computation. It's more powerful, it's accessible almost everywhere. I can carry it around in my pocket. That's kind of Moore's law stuff, so no big surprise there. The other thing is data. Data is available in terms of rich data sets. We've got real-time data coming in, and the data is only growing and growing and growing over time. It's data, it's data, it's data. We like data. In fact, so much so that we're calling this field not AI or machine learning, we're calling it data-driven intelligence, because that's based on the combination of machine learning and data. It's not about the data, it's not about the machine learning. The two are one. And we think this is a fundamental capability that's giving us the ability to do new things. So much so that we're not going to just see it in a few places. We're going to start to see this everywhere. We're going to see data in more places than we'd expected. And another reason for that is that it's getting easier and easier and easier to use this stuff. I no longer have to have a PhD from MIT to do it. I no longer have to have 10 years of experience in the field because I don't have to create my own frameworks for doing it. Other people are doing that for me, and I can just tap into a framework that exists, like TensorFlow, and have it tell me how many cats are in this picture, how many people are in this room, how crowded is the train, what's the current demand on the grid. So what this means is you're going to start seeing machine learning show up in more places. And this is kind of a long tail phenomenon of what's happening. You don't have to solve the big problem. You can solve the small problem. You might even be able to solve it pretty easily. You can certainly prototype it pretty easily. And we can start picking these things off pretty quickly. So think about all the little problems, little tasks in your business that you might need to take on, and you can start addressing them. What does that look like? So a couple of themes. Dean actually mentioned a lot of these themes, so my work's done for me. Interactions. New uses of AI in new places. Personalization, it gets better at working with us. In turn, we get better at working with it. Finally, decision making. This is going to start with augmenting our ability to make decisions, which I'm notoriously bad at, so that's great. And maybe even making decisions for us, even better because I hate making decisions. So interactions. The first interaction is something we're already getting used to. We've been used to it for a little while with Siri. That wasn't super intelligent. Echo's getting a little bit better. Natural language processing is making it such that we're expecting AI in the form of bots, typically, to show up in more places and places we haven't seen in the past. But we're also interacting with AI without even knowing about it. It's happening in the background. algorithms are getting tuned to our usage and getting smarter without us even knowing it. So right now I get better recommendations. Maybe Stitch Fix sends me a shirt automatically that it thinks I'm going to like. But that's going to get better and better over time and be applied to more things. So let's go back to an old example. This is a prototype we built all the way back in January called vFarm. vFarm is a NLP-based bot for administering medication. And this team was looking at how do we bring a voice interface and a bot into the field of medicine. And one of the fellows working on it was working in rural communities where you can't necessarily bring in a bunch of sensors or a smart pantry to do inventory in real time, but you can bring in a voice interface and say, hey, vFarm, I'm using 100 milligrams of ibuprofen. And in this case, they also built a platform where the bot can tell you, actually, you just picked up acetaminophen. That's not right. Help correct that. But the voice interface allowed me to do things like put it in new places and do something else at the same time, like use my hands. So I'm not typing. There's another prototype here today, NeuroWatt, you may have gotten a chance to see. This is a home electricity management system where you're actually training the neural network just by using it. So when you go to heat your home, charge your electric vehicle, take a shower, something like that, it's learning your behaviors and getting better over time. Personalization. So here we're starting with recommendations, but moving into predicting behaviors outright. So an example of that here today is GUIBot, the commuter bot that you may have seen over in the corner here. This is looking at real-time data from hyperlocal weather, from train delays, and from occupancy, and using that as a way to make a recommendation to you based on your personal preferences of how you want to get to work, especially when you have multiple modes of transportation available to you, if you want to take the bus, take the train, et cetera. That will get better over time, and we imagine that being able to take on the whole system where you're balancing the load of an entire transportation network according to people's personal preferences. Finally, decision making. And here we're back to war games again. The only winning move is not to play. In this case, we're analyzing and interpreting the data and maybe even taking action on it for you. So here you can see a prototype, Spark Fleet. This is kind of like NeuroWatt, but at the fleet level, where you have a fleet of electric vehicles, each of which has a battery, each of which has a origin destination, someplace it needs to go. How do you balance the energy needs of all of the players in that system with the energy availability of the batteries? Do you put the energy back on the grid? Do you use it to get from point A to point B in a fleet? This is something that, I could almost imagine a human doing, but they're going to need some help, and it would be way, way better if you could start to automate it. So those are just 3 examples of interactions, personalization, and decision making. But what's really interesting about them is that they're actually pretty much possible now. This is not AI 30 years from now. This is not going back to the conference and hearing the same claims. You actually can start addressing these things with the tools that are out there today. You don't have to go and build an entirely new platform to do it. And what's more, the ideas of what to do are kind of already out there. They're already in your business today. There's enough intellectual capital that's been banked that can be spent down because these problems have already existed for a long time and because you don't have to worry about the big ones. Do the little ones first. So, what's next? So I think what I'm talking about in a lot of cases here are you might call AI-augmented products. They're things that we're already pretty much doing. They're just getting better because I'm building some smarts into them. Nothing wrong with that, by the way. But there might be a shift that we see in the future where we move to AI-native products. And a couple analogies here to help with that. One is, imagine you've got a brick-and-mortar store and you add a website. Are you an internet company? Not necessarily. Building an internet company from the ground up says, I'm going to start with the internet as a core technology. That's my platform. I'm going to make an entire set of products and services on top of that, and then maybe buy Whole Foods later. Another example, near and dear to my heart, actually comes from the world of instrument building. So go back to like the 1920s. Jazz is getting more popular. Dance bands are getting more popular. Music's getting louder. Electronic amplification is coming on the scene. And what you started to see was guitars that looked like this, that were designed to put out as much acoustic volume as they could, getting augmented with a pickup. And that's a retrofit. After a while, obviously, they started making these acoustic guitars with a pickup on it, but it was still kind of like an acoustic guitar with a pickup. And even today, I can go and buy an acoustic guitar and a sound hole pickup and give that the capability of being amplified electronically. But I haven't made an electric guitar. And it wasn't until Les Paul came along in the 40s and said, you know what, forget acoustic resonance. I'm going to make a guitar around this fundamental new technology of electromagnetic pickup. So he took a slab of wood, he bolted on two wings from an old archtop guitar, mainly for looks and ergonomics. In fact, you can see this is filled. So he's not using any of the acoustic resonance of the instrument at all. He's saying, this is a new capability, and I'm going to build an entirely new instrument around it. From there, this got refined into the Les Paul that we know and love. About the same time, Leo Fender made the Stratocaster, new ergonomics, totally new experience of making a guitar. Mass production, this is way more mass producible, by the way, because it has a different construction. And that led to all the crazy guitars you see today. These are just a few examples that I think are nice because they don't look like an axe or something like that. So that evolution, in turn, led to an entirely new form of self-expression, a new experience, a new technology, led to a new design of an experience that led to an entirely new form of music. And here it's not about the guitar, it's not about the pickups, it's about what you can do with it. So, thanks.